congruent triangles, so we want to be able to name and use corresponding parts of congruent polygons to prove that triangles are congruent. So congruent we've used lots of times before, but just a reminder, it's when geometric figures have the exact same shape and size. That's when they are congruent. Corresponding parts are the matching parts of the congruent polygons. The third angles theorem says that if two angles on one triangle are congruent to two angles on a second triangle, then the third angles are congruent. And CPCTC stands for corresponding parts of congruent triangles are congruent, and this is something we'll use in proofs. So first example says show that the polygons are congruent and identify all the congruent and corresponding parts, then write a congruent statement. So on here we got kind of lucky because these are oriented the same way, so it's easy to tell which pieces are congruent. So I'm going to label or identify the parts that are congruent here. So A is congruent to R. So first I'm going to list out all the angles. I have E and Q. D and S. C and P. And B and T. Okay, so those are all the angles, but now we also need to list all of the sides on here. So I have AE and RQ. We have ED and QS. DC and SP. CB and PT. And then BA and TR. Okay, then the last piece is write the congruent statement. So writing the congruent statement is important because they have to go in order that they are matching up on. So if I go A, E, D, C, B, I have to match those up with the corresponding parts in the same order over here. So I'm going to say A, E, D, C, B is congruent to. So if I started with A, I have to start with R because that's the corresponding piece. And then E goes with Q, S goes with D, and so on. So you have to make sure that they go in order because that makes a difference on your congruent statement. So this right here is the congruent statement. Okay, example 2, we're using this picture. It wants us to find the values of x and y. So it tells us here that ITP is congruent to NGO. So this is the congruent statement, which tells us that angle I goes with angle N. So this goes with that. Angle T goes with G. So T and G match up, and P and O match up. So I can start with that right off the bat. I'm going to start with y here. These angles have to be equal to each other because they're corresponding parts of congruent triangles. So I'm going to say 6y minus 14 equals 40. And then I will add 14 to both sides. And then divide both sides by 6. Y will equal 9. Then for the x value, so I know y, so I can substitute that in here. So if I do 2 times y, this is really becoming x minus 18, because that was a 9 in there. So this side, I have to figure out which of these sides goes with that side. So it's the side between n and g and g correspond with I and t. So that means this side is congruent to this side. So I'm going to say x minus 18 has to equal 7.5. So I would add 18 to both sides, which gives me 25.5. Alright, example 3. This is a drawing of a tower's roof, and it's composed of congruent triangles all converging at a point at the top. So we have angle J and K are congruent to each other, and J is 72 degrees. So what's the measure of JIH? So that's this angle up here we're trying to find. So what I really have is I have an isosceles triangle, which means those base angles are equal. So that's 72 and that's 72. So we're going to use that third angle theorem. So if I do 180 minus 272s, that means that that top angle is 36 degrees. Alright, and the last one here says write a 2-column proof. So all this stuff is given for us. L is congruent to P. LM is congruent to PO. Oops, sorry, LM and PO. LN is congruent to PN. And MN is congruent to OP. So first we're going to start with the given on there. So if we write out our given, first we'll do our statements and reasons. So angle L congruent to angle P, LM congruent to PO, LN congruent to PN, and MN congruent to OP. So that is all given. Okay, so now I have a lot of the parts already given to me here. So I know that this angle in here, those two are going to be equal to each other. So I'm going to say angle LNM. And we want to make sure we go in the right order here. So angle L goes with angle P. So when I list off this other one, I'm going to say PNO. And those are vertical angles. So that's the vertical angles theorem. Now, the only other piece that I don't have on here is this angle over here. Everything else has been marked as congruent. So now I can say angle M is congruent to angle O. Now notice here I only needed one letter to describe that angle. I can't just use N to describe this angle because there's like 4 angle N's on there. So these two I can just use that one letter, and that is because that's the third angle. We already know that these two angles are equal, so that means that one has to be equal. So this is third angle theorem. And then lastly is the thing that you want to prove. So now that we have all the pieces congruent to each other, all the corresponding parts, triangle LMN, PON, this is that CPCTC. Corresponding parts of congruent triangles are congruent. So since we have all of the pieces equal to each other, I can say that the triangles are congruent. Alright, so you're going to use this little picture over here to answer these two questions. And for your joke, why do seagulls fly over the sea? Because if they flew over the bay, then they'd be bagels. Alright, hope you have a great rest of your day, and make sure you're kind to someone today.